next year. So yesterday and the day before, we talked about the fact that slope is just the rate of change. It's how fast something is changing. Now, if we apply that example to somebody that's moving from one place to another, right? So your position is changing. Where you are is changing. Then how fast your position is changing is your what?
Velocity.
It's your velocity. So how fast you get from one place to another, that's your velocity. So if we have a graph, and if that graph is not just some random function, if it's actually a graph of our position, okay, so let's call it distance. All right, so at t equals 0, I was here, or at t equals 1, I was here. And at t equals 5, I was here. Okay? So let's see, how far have I traveled? I've traveled from 2 meters to 10 meters. And how much did it take me to make that journey? It took me 4 seconds. Okay? So now we're not just talking about any change. We're talking about a change in position. I start from here and I get there and it takes me 4 seconds. Now, if I find the slope here, that's in the physical context, the slope is how fast my position went from here to here. That's my velocity. That's my speed. Okay? So the slope, when you're talking about a position graph or a distance graph, is velocity. Okay? So velocity is the rate of change of an object. And average velocity is the total distance traveled divided by the total time it took you to make that distance. Okay? So if you traveled a total distance of 8 meters and it took you 4 seconds to do that, then 8 meters over 4 seconds is 2 meters per second, and that's your speed. That's your velocity. All right? So in each case, slope stands for something different. When you're talking about distance, slope stands for velocity. Okay? Yeah.
For the next problem, do you want us to change feet per second into meters per second?
No. All right, so how do we do this? How do we do this? How do we figure out that, first of all, we traveled a distance of 8? How do we figure that out? Well, because we started at 2, we ended at 10, so I took the final position minus the initial position, and that got me the total distance. Okay? So I took f of x2 minus f of x1. Now, instead of x1 and x2, can we label these a and b? We can. It's up to us how we label anything.
Why not?
So here, instead of f of x2 minus f of x1, I just call it f of b minus f of a. So this is the position, my final position minus my initial position over the total time. Okay? This is the final time, 5 seconds, minus the initial time, 1 second. So we're taking the concept of slope, which you've done in the generic case forever, and now we're applying it to this particular case of changing position, and in this case the slope represents velocity. Okay? Alright, so we're going to use this to find the average velocity. And, to give you a different example, suppose you're driving to Vegas and you drive a total of 300 miles and it takes you 4 hours to get there. So on average, what was your speed? 300 miles over 4 hours. On average, your speed was 75 miles per hour. Okay? That's essentially what we're going to be doing in this problem. So this specific problem says a water balloon is propelled straight up using a launcher. The height of the balloon in feet, t seconds after it is launched, can be defined by this. So this is the equation that tells you the position of the balloon. Okay? And I underline the units so it's visible and I can use it in my problem later. What was the balloon's average velocity between t equals 1 and 2? Okay? So we're going to use this formula that says V average is f of b minus f of a over b minus a. Now, in this problem, this is A and B. My initial time and my final time are my A and B. So let me just make a list of everything I have here. I have that A equals 1, B equals 2. What I also need is f of A and f of B. So let's find those. F of A is what I get when I plug A into here. Except now we're talking about distance and my variables have changed to D. So let's just make that change here. So this is D of A, which is going to be 5 plus 65 minus 16. So D of 1 is 54 feet. So that's the position at t equals 1 second. That's where the balloon is, at 54 feet. Now, D of B is D of 2. So how much is D of 2? It's 5 plus 65 times 2 plus minus 16 times 4. So D of 2 is what?
71.
71 feet. And does that make sense? We're talking about a launcher that launched this balloon straight up. 1 second after it's at 54 feet, and then in the next second it's higher at 71 feet. So yeah, so far that's making sense. All right, so let me just modify the variables here to reflect what I have. So f of b minus f of a, really that's going to be d of 2 minus d of 1 over 2 minus 1. Now, d of 2 we found to be 71 feet minus 54 feet over 2 seconds minus 1 second. So how much is 71 minus 54? 17 feet per 1 second, meaning this is 17 feet per second. So on average, this launcher is moving up at a rate of 17 feet per second, at a speed of 17 feet per second. Okay? Now, this is average speed. The total time, the total distance divided by the total time, so on average it was going up at 17 feet per second. When we talked about going to Vegas before, and we said that your average speed was 75 miles per hour, were you really going 75 the entire 4 hours?
No.
No. Sometimes you were going at 65, sometimes it may have been at 85, sometimes it may have been at 90. Okay? Sometimes there may have been a few points in time where you looked at the speedometer and it was 75. Okay? But the entire time you were not going at 75. It was fluctuating. So that's the difference between average and instantaneous velocity. Instantaneous velocity is directly the reading of your speedometer. So if you look down at your speedometer and it says 78 miles per hour, that's your instantaneous velocity. So when you're going to Vegas, at some point it may have been 78, at another point it may have been 68, at another point it may have been 75. All of these are your instantaneous velocities. If you averaged all of them, it would be 75. All right. So the instantaneous velocity is the velocity of an object at a specific point in time. So it's exactly what we talked about yesterday. It's the slope of a function at a specific point. And if you look at the homework that you did yesterday, when you had to find the slope at a specific point, that's what we're talking about. Okay, so these problems right here. All right, so let's look at this example. To find average velocity, to find instantaneous velocity at a certain point, we're going to use the limit as h approaches 0. Okay? So same thing as we did before. We are modifying the limit somewhat to reflect t for time. Okay? So it applies to our problems here. Alright, a window washer accidentally drops his lunch off his scaffold at 1,400 feet above the ground. The position of the lunch in relation to the ground is given as this. Okay? This is a basic formula for any object that's falling freely. You just plug in your specific parameters, like where it fell from, was it at rest when it was falling, and you get this.
How come in both problems we do minus 16 t squared? Is that a standard thing?
Here and there?
Yeah.
Yeah, it's part of the problem when something is in free fall, whether it's just going up or it's vertically going down. That's part of the equation.
Is it like gravity? Is that why?
It's related to that, yes.
Okay.
So time is given in seconds and the position is given in feet. Find the instantaneous velocity at 7 seconds. So what we need to find is v of 7. Okay? So t is 7. What we're going to do is use this formula. The limit as h approaches 0 of f of 7 plus h, not f, d. d of 7 plus h minus d of 7 over h. So let's do some of our preliminary work here. I want to first find what d of 7 plus h is. It's 1,400 minus 16, 7 plus h squared. So this is 1,400 minus 16, 49 plus 14h plus h squared. 1,400 minus 16 times 49, 784, minus 16 times 14, 224h, minus 16h squared. All right, so that's that. Next, d of 7.
How'd you get 22h?
224h. d of 7 is going to be 1,400 minus 16 times 7 squared. 616. Okay?
Is it 224h or is
Yes, 224h. So let's plug all that in here. The limit as h approaches 0 of d of 7 plus h. Now this will give us 616 minus 224h minus 16h squared minus 616 over h. So that's the limit as h approaches 0 of, all right, now these will go away. And I told you before that we can cancel out this h with each of these. You just have to be careful that you cancel one from every single term though. And we get, finally, limit as h approaches 0, negative 224 minus 16h.